So in our last lesson, we talked about geometry in a 2D world. Now we're going to talk about it in a 3D world. So that's what we mean when we say geometric solids. So let's start very simple. Let's start with surface area, which is kind of like a combination of the 2D world and the 3D world. So of course, it is a good place to start. So, surface area. This is a very, very complicated definition. Switch colors. It is area of the surface of an object. So we measure it, surface area in the same way we measure regular area, in inches squared, or centimeters squared, or sometimes feet squared. So to give you an example, this is a 1 centimeter cube. I call it a 1 centimeter cube because it's a cube that's 1 centimeter in every direction. If I look at one side, then we're only looking at a 2D shape. Do you agree? It's 1 centimeter by 1 centimeter. It is 1 square centimeter, or 1 centimeter squared. How many sides are on this? 6. There are 6 sides on a cube. So this is 1 square centimeter. This is 1 square. This is 1 square. This is 1 square. What are we at now? 4, 5, and 6 square centimeters. That's what we mean when we say surface area, the area of every surface of our object. Are y'all with me? This is a square inch. It follows the same rules, but with inches instead of centimeters. This is 1 square inch. Does that make way too much sense? So what is the total surface area of this cube? 6 square inches, or 6 inches squared. When we say 6 inches squared, I mean literally there's 1 square, 2 squares, 3 squares, all the way up to 6, and they're all an inch. That's all surface area means. So this is a 1 centimeter cube. We'll say this one's a 2 centimeter cube. And here's a 2 centimeter cube divided into centimeter cubes. If it's 2 by 2, we have 4 square centimeters. So how many square centimeters do I have total on this cube? 24, because it's 6 times 4. This also has a surface area of 24 square centimeters. I mean, literally, you can count 24 squares that are a centimeter in size. So let's sketch an example and kind of prove the formulas for surface area real quick. Let's skip about 3 lines, and you'll recall this. Draw a 2 by 4 rectangle. You'll recall this sketching technique from our oblique sketching lessons. But draw yourself a 2 by 4 rectangle about 3 lines below. And then what I want you to do is from each corner, go back 2 diagonals. And then all I want you to do is connect the back. Let's go ahead and give this some dimensions. We'll start over here on the left. I'm going to call it 2 inches tall from bottom to top. Then from left to right, I will call it 4 inches because it's 2 by 4 because math. So I'm just calling each square an inch. Then from front to back, we will call it 4 inches as well. So if I want to figure out the surface area for this rectangular prism, we could just go to the back of our notebook and look up the formula. But the formula is kind of intuitive. It's kind of obvious. So for example, this is the height. Let's label this as the height. This is the width. And this is the depth over here. If I wanted to find the area of this one face, you don't have to draw these lines. I'm just going to divide it into different squares. Okay, how many squares do I end up with? 8. How did I get that? Well, it's 2 times 4. But do you agree that the back is the same as the front? So the front and the back have the same formula. In other words, I'm going to say 2 times my height multiplied by my width. Then from there, I'm also going to figure out the surface area of this side. Well, that's going to be my depth by my height. But do you agree that the right side is the same as the left side? So again, I'm going to double it. I'm going to say 2 times the height times the depth. And then I'm going to do it one more time. I'm going to do the top and the bottom. So the top is the width by the depth. So I'm going to double it because the bottom is the same as the top. And then I'll say, okay, width times depth. Now we can go ahead and plug in our numbers. So we'll say equals. 2 is still 2. What is our height? And what is our width? So we'll say 2 times height is 2 times width is 4. Plus 2 is still 2. What is our height again? What is our depth? So this is 2 times 4. Just plug into my numbers. Plus 2. What is our width? What's our depth? So 4 times 4. And so hopefully this is way too obvious. But the point I'm trying to get across here is we just made up the formula on our own. If you check in the back of your notebook, you will see the exact same formula written down. All we did was prove it. Because if you understand the formula, you will be far better off than if you just look it up every time. So now what is 2 times 2? Times 4? 2 times 2 is not 8. What did you say? 2 times 2 is? Times 4? 16. And these are inches squared. So I'll say inches squared. Plus 2 times 2 is? Times 4? 16 inches squared. Okay, that's really easy. Plus 2 times 4 is? Times 4? 32 inches squared. 16 plus 16 is 32. 32 plus 32 is 64. So we'll say the surface area of our box, so I'll say surface area B equals 64 inches squared. And I'm going to go ahead and add that up here as well. Surface area of our box, or a rectangular prism. You could put an R instead of a B, I guess. I'm going to leave it as a B for now for simplicity's sake. But anyway, hopefully this makes way too much sense. Let's do the same thing, but with a cylinder. So what I want you to do is go down a line or two. And we're going to draw an ellipse to represent a cylinder. I'm going to draw one little line here, and another little line 2 below it. And I'm going to mark a center here. I'm going to go to the right 2, mark a little mark. Go to the left 2, making a little mark. And so I've sort of sketched an ellipse that looks like it's 2 by 4. In reality, I drew a circle that just sort of elongated. But go ahead and finish off this little ellipse, and hopefully you'll see what we're sketching in just a second. Now, from this corner right here, what I'd like you to do is go down 5. 1, 2, 3, 4, 5. And then do the same thing on the other side. Go down 5. 1, 2, 3, 4, 5. Then all I'm going to do is connect these with a little half ellipse, and hopefully you see the cylinder that we've sketched. Let's go ahead and give this some dimensions. It's 4 squares wide, so let's call our squares this time. Let's call them centimeters for this. So I'll go from left to right and call it 4 centimeters. And then going from the bottom all the way to the top, that's 5 squares. I'm going to call that 5 centimeters. Let's calculate the surface area of our can or cylinder or whatever you would call it. I'm going to call it surface area C for cylinder. So instead of looking up the formula, we could do that to double check our work. Let's prove the formula. So let's take a piece of paper and let's roll it into a cylinder. Look at that. Do y'all agree that this is a cylinder? More or less, pretend like it's a perfect circle, I guess. Now, if I wanted to find the surface area of this round part here on the sides, do you agree that it would be equal to if I rolled it out completely? So the height is the height. The height is still 5. We know the height. But the circumference is then equal to the length of this base. It's just like a rectangular prism. Or, I'm sorry, just like a rectangle, calculating the area of a rectangle. Just rolled into a ball. But the area of that length doesn't change. The circumference just becomes the length of our base. Well, what is the formula for the area of a rectangle? Base times height. Our base is essentially the circumference of our cylinder. What's the formula for circumference? Pi times diameter, or 2 pi r. That's our base times our height is height. But we also have two circles, one on bottom and one on top. So we need to add those. What's the formula for the area of a circle? Pi r squared. And there's two of them, so I'm going to double it. So plus 2 pi r squared. And so that's it. That's the formula for the surface area of a uniform cylinder. And we know all these numbers, so we can go ahead and plug them in. 2 is still 2. Pi is still pi. R is, what's our radius? 2. And what's our height? 5. Plus 2 is still 2. Pi is still pi. What's our radius again? 2. And then we square it. Okay, so 2 times 2 is times 5. So this simplifies to 20 pi. And then we could say plus 2 times 2 is, oh, let's square it first. 2 squared is 4 times 2. So we get plus 8 pi. And so then I can simplify this to become 28 pi. And then if you go ahead and type this in your calculator, I'll go ahead and tell you what it is right now. Surface area, you can feel free to check my math with your calculators in front of you. But its surface area of the cylinder is, you will get 87.93 centimeters cubed. I think you might get 9.2, or 9 centimeters squared, sorry. I think you might get 0.92. You got 9.6. All right, well, let's adjust it. I think it depends on whether or not you round 3.14 or not, but doesn't really matter. Hopefully you get the idea as how to use the formula.